Hey, welcome back. This is now the review for the upcoming test. All Chapter 7 material, so I won't be putting the 4.5 section on Test 2. We'll just delegate that to the homework. So here we go. So the first section was 7.1, and I'm looking at questions similar to 21 to 75 odd from the book. And these are all problems where we were asked to simplify rational expressions. Okay, so simplify. So let's just, I'm just going to take a look at a whole bunch of them. And what you do is what I would advise you to do is maybe pause the video and see if you can get the answer on your own. And that's a pretty good practice for the upcoming test. In addition to that, you can go to the book and find questions that are similar to the ones I'm doing and do those for more practice. Okay, so let's take a look. The way we are simplifying here in algebra is factoring. So in the numerator, I could factor out a GCF of 3. Denominator, you could factor 6 into 3 times 2. And then you see there's a common factor of 3, which we can remove. That will be replaced with 1 over 1. So in the numerator, we have just the factor of x minus 3. In the denominator, we have 2x. And you can leave the parentheses there for me. That's okay. In the future, though, you kind of want to write it without the parentheses. It's x minus 3 over 2x. Okay? Next, so we're just going to do a ton of examples. Okay? X plus 2 all over x squared minus x minus 6. Okay. So in the numerator, we just have the factor of x plus 2. In the denominator, we'll have some factoring to do. So it's got to be plus minus with the 3 and 2 with the bigger number negative, like that. Okay. Then I can remove common factors. And I'm just left with 1 all over the factor of x minus 3, which you could just write as 1 over x minus 3. Next, 48. We have x squared minus 14x, plus 49 all over x squared minus 49. Okay. I'm going to factor the numerator and the denominator. Looks like the numerator is a perfect square trinomial, minus minus, 7 and 7. The denominator is a difference of squares, plus 7, x minus 7. So the common one, the x minus 7s are the same. You may think those are opposite factors, the x minus 7 and x plus 7, but remember, you have to have opposite signs on each one. So see, x and x, they both have the same sign, so they're really not opposites. And so you're just left with the x minus 7 in the top and the x plus 7 in the bottom. Okay. Okay. 68. We have 9, which I wrote as an upside down 9. 9 minus 15x all over 5x squared minus 3x. Okay, so again, we're factoring out common factors. In the numerator, we could factor out 3, and we get 3 minus 5x. In the denominator, we could factor out an x, and we'll get 5x minus 3. Okay, this one then, they are opposite factors, right? 3, negative 3, negative 5x, positive 5x. So those are opposites. You replace the top one with a negative 1 and the bottom one with a 1. And so on the top you have 3 times negative 1, or negative 3. And the bottom you have x times 1, which is x. And of course you could write that as negative 3 over x if you'd rather, but either answer would be full credit for my test. Okay. 74. xy minus 2x all over 3y minus 6. Again, factor out GCFs. So in the numerator we got an x, then y minus 2. In the denominator we got a 3, so that would be y minus 2. And then we can remove our common factors. And we're just left with x over 3. Okay. One more in this section. 78. We have x cubed minus 8 all over x squared plus 2x minus 8. And so that thing in the numerator is a difference of cubes. So if you want, you could identify A as x and B as 2. And we use the SOAP signs, so same sign, opposite, always positive. This will be x minus 2, and then x squared plus 2x plus 4. And then that's all over this other thing, which I'm going to factor, or try to, at least. So this will be x plus x minus 4 and 2. With the bigger numbers, has to be positive. And then we can remove the x minus 2's, and we're just left with x squared plus 2x plus 4, which is not factorable, all over x plus 4. Okay. And so, you know, that's what you're up against for 7-1. It's just a bunch of simplification. Make sure you know that cubic formula. That could pop up on the test again. Okay, so 7.2 now. I'm thinking of problems like 1 to 63 odd. And here what we were doing, if you've forgotten, is multiplying or dividing. So you just, you know, multiply straight across, you're factoring as you go, and then you're simplifying. Okay? And then division is just one extra step where you multiply by taking the reciprocal of the second expression, or the second factor, I guess. Okay, so let's take a look. We have x over 5 times 30 all over x minus 4. Okay, so you can almost do your cancellation automatically if you want, but I'm going to go ahead and kind of do the factorization just to be consistent with what we teach. Downstairs I have the 5 times the x minus 4. Okay, so I have this common factor of 5. You can remove those. In the numerator, I'll just have x times 6, or we like 6x. Put that number first and then the variable. Downstairs, 1 times the x minus 4. Okay, and then that's it. There's no more common factors, so you can rewrite it or leave it as it was. But that would be kind of the official answer. Okay, let's keep moving. Okay, so this one's one of the monster kind of factoring problems. Y plus 10, 3y squared minus 22y minus 16, and then times y squared minus 4y minus 32 all over y squared minus 8y minus 48. Okay, so factor. So the first thing looks like a 3y, and then maybe a 5 and a 2, and then plus plus. The next portion from the next numerator, y and y, plus and minus 8 and 4, with the 8 negative. Downstairs, 3y and y, it's going to be plus minus somehow, so probably an 8, right? With that negative, that gave you that 24, and then plus 2 here. And then finally this guy, it's got to be plus minus. You know, 6 and 8 won't work, so you try 12 and 4, that'll work, with the 12 is the negative. Okay, so go ahead and remove common factors. And we were just getting y plus 5, a factor of y plus 5 in the numerator, and that factor of y minus 12 in the denominator. And then you're done. You can't remove anything. Next, 26, I have 8x plus 2 all over a difference of squares times 3 minus x all over 4x squared plus x. Okay, so same spiel. Going to factor out a 2 from the first factor of 8x plus 2. You end up with 4x plus 1, and then times 3 minus x. And then downstairs, we can do a difference of squares, factorization, x plus 3, x minus 3. And then you could factor an x out of the next term there. So you have 4x plus 1 And we see some canceling. So first the 4x plus 1s are gone, obviously. The 3 minus x and the x minus 3s are opposites. So you replace that 1 in the top with a negative 1. And that's it. So in the numerator we get negative 2. In the denominator I have an x and then an x plus 3. Okay. And we like to put the x before the x plus 3. So you wouldn't normally see x plus 3 then times x. Okay. Okay. 42, 4 all over x minus 6 divided by 40 all over 7x minus 42. Okay, so it's almost exactly the same as multiplication. It's just you have this one additional step where you replace the division symbol with a multiply, and then you flip or take the reciprocal of the second term here. So let's now factor 4 times. I could factor 7 out of that second numerator. And you have x minus 6. In the denominator, you have an x minus 6 times. You can get a factor of 4 out of 40 easily. And then you see, all right, I can get rid of those. I can get rid of those. And you're just getting a fraction 7/10. Okay. So 2 more of these. Let's get 46. Y squared plus 4y minus 5 divided by, this whole thing divided by y squared minus 25 all over y plus 7. Okay. So first I'm going to rewrite that first quadratic as a fraction. So y squared plus 4y minus 5 over 1, right? And then I'm going to change the division and the multiply and take the reciprocal of the second fraction. And you could start factoring as you go along, but I'm going to wait until now. Okay, so now I can factor that trinomial, I believe, I hope. And then I got the y plus 7 downstairs. I could easily factor the y squared minus 25, y minus 5, y plus 5. Okay, numerator y and y, it's got to be plus minus, and then 5 and 1 with the bigger one positive. Okay, remove factors, and that's about it. That's about all you can do. Y minus 1 times y plus 7 all over y minus 5. You can put that in parentheses if you want. You don't need to, though. All right, next. Last one in this section, 54. 3y squared minus 12 all over y squared plus 4y plus 4, and then divided by y cubed minus 2y squared all over y squared plus 2y. Okay, here we go. I'm going to go ahead and start factoring. So we have a 3 times y squared minus 4 in the first numerator. That bottom looks like a perfect square trinomial. Y plus 2, y plus 2. Then times, and I got to take the reciprocal. I'm not going to do too much at once. That's usually when I start screwing up. You do enough math, you start getting an idea of what your weaknesses are. Anyways, here I'm factoring the perfect square, y plus 2, y minus 2, and then times this other thing. I can factor out a y, and I get y plus 2 left over. Downstairs, I already got the y plus 2's factored, this from the perfect square trinomial. And then the second denominator, I can factor out y squared. I'm left with y minus 2. Okay, ton of cancellation. And then you're left with 3y all over a y squared. And of course, you could bring the y down, and you'll just have 3 all over y to the 2 minus 1, which will be 2. So remember, if you have a to the x all over b to the y, or a to the x over a to the y, you can always rewrite that as 1 all over a to the y minus x. Okay? So those exponent rules are extremely important later on in math. You sort of have to be the master of them. But you could always factor it if you didn't like that approach, or you get caught sort of with your pants down, so to speak. You could always rewrite this as 3y all over y times y, and then remove the y's, and you just get 3 over y. Okay, but you have several options. Okay. 7.3 then is on adding and subtracting, but with like denominators. So addition and subtraction, I'll be looking at problems like 1 to 63 odd. Okay, so let's dive right in. At number 22, I have x squared plus 9x all over 4x squared minus 11x minus 3, and then plus 3x minus 5x squared all over 4x squared minus 11x minus 3. Okay, so all we have to do is add the numerators over the common denominator. So I have x squared plus 9x plus 3x minus 5x squared all over this common denominator. Combine like terms in the numerator, so I'm getting 12x minus, that'll become 4x squared. And the denominator, I think I'm going to be able to factor that and simplify. So it's not just adding them together. You still have to simplify if you can. So I can pull out, I think, a 4x, and I get 3x minus 3 minus x. Excuse me. Downstairs, it looks like if you get a 4 and a 3, maybe you could get a nice 11 in between. Okay, with a minus there and a plus 1. Yeah, and then there's opposite factors. So this and this are opposites. You replace the top with a -1, and the bottom with just a 1, and then you get negative 4x all over 4x plus 1. Yeah, okay. Let's go on to a subtraction version. So 32, yeah, x cubed minus 3 is a difference. No, it's not a difference of cubes. All over 2x to the 4th minus 7x cubed minus 3 all over the common denominator of 2x to the 4th. Okay. So subtract the numerators over the common denominator, but you have to remember to distribute that negative. So if you wish, you could write that second numerator in parentheses like that, and then the next step will distribute. Okay, so I'll have x cubed minus 3 minus 7x cubed plus 3 all over 2x to the 4th. Looks like the 3's are canceling. You get negative 6x cubed all over 2x to the 4th. Negative 6 over 2 is the same as 3 over 1. And then we could do a subtraction of exponents. So we end up with negative 3 all over x to the 4 minus 3, which should just be x to the 1, so negative 3 over x. Okay. Or if you need to, you could factor it into x times x times x all over x times x times x times x, and then remove common factors. But it's just a bit of work. Seems like more work than it's worth. 60, and especially if you end up with a question that has x to the 12th all over x to the 20th, you're gonna say no. I'm gonna figure out a different way to do this. Okay, anyways, 2x, there won't be one like that on the test though. So 2x minus y all over x minus y plus x minus 2y all over x y minus x. So this is one of those ones where you have opposite denominators, and our sort of trick, you can think of it more in one way. I think I taught you to change the sign and then reverse the second denominator. So change this to a minus of x minus 2y all over x minus y, and then we can distribute the negative. So 2x minus y minus x minus 2y all over the x minus y. Then we get 2x minus y minus x plus 2y all over x minus y. 2x minus x is x. 2y minus y is plus y all over x minus y. And then you're done. Those are not opposite factors. Okay. Okay. Another way you could have done it was to multiply the second term top and bottom by -1. So just in case you would prefer that method, you can multiply the top by -1, x minus 2y, and the bottom by -1, and it'll effectively do the same kind of, sort of it'll have the same sort of behavior. So you'd end up with 2x minus y all over x minus y. If you distribute this negative 1 here, you'll end up with negative y plus x. And then from the commutative law of addition, that's exactly the same as x minus y. Okay, so you end up with that denominator that you want, plus negative 1 times x minus 2y all over x minus. It's the same thing though, right? Because now you're going to be plus this negative 1 times x, just plain old x minus 2y all over x minus y. You'll end up then right here. Okay, once you distribute that negative, and then you'll get the same answer. So either way you want to slice it, I don't care. Either way is fine. Okay, so that's about the worst of it in 7.3. 7.4 then, now we're adding and subtracting with unlike denominators. And I'll be considering questions like 17 to 81 odd. Okay, and let's look. So 24, starting with, you have 3 plus 1 over x. Okay, I want to add these, find the common denominator, and add. So 3 is the same as 3 over 1. It's 1 over x. So to get the common denominator, that first denominator is missing a factor of x. So I need to multiply top and bottom by x, and then I'll have the same denominators. Okay. And then I add the numerators over the common denominator, and I'm good to go. Okay, I'm done. Simplify if necessary. This time it wasn't. Okay, let's look at another. 3 all over y plus 1 plus 2 all over 3y. Okay, so the first fraction is missing a factor of 3y, so I have to multiply top and bottom by 3y. The second factor is missing that y plus 1, so top and bottom y plus 1. Okay, so I'll have 9y 9y all over the 3y times y plus 1 plus 2 times y plus 1. You could distribute if you wanted to, but I'm just going to all over 3y times y plus 1. Combine the numerators over the common denominator, and I'll distribute in the next step. Okay, just being very kind of careful to do the process that I established in the previous video. I need to distribute the 2, so I'll have 2y plus 2 all over 3y times y plus 1. 9 plus 2 is 11 y's, then plus 2 all over 3y times, and that's it. You can't simplify at all. There's no common factors. Okay. Okay. Let's get. Looks like I have 4 more examples in this section. So 42. I have 8y all over y squared minus 16 minus 5 all over y plus 4. Okay, so this time I'm going to have to factor to kind of see what I'm dealing with, because what you don't want to do is just blindly multiply in to create a common denominator, because what you'll end up doing is over multiplying. Okay, over prescribing sort of. So if you look at y minus 16, y squared minus 16, that's actually y minus 4y plus 4. Right? So the moral of the story is you kind of already have the common denominator in that first denominator, and all you have to do on the second denominator then is to multiply in the y minus 4. Okay. Okay, so let's subtract the numerators over the common denominator. I'm going to need to distribute this negative 5. So I have 8y minus 5y plus 20. And then I'm going to end up with 3y plus 20 all over y plus 4, y minus 4. And we always like to simplify if we can, but in this case, no, you can't simplify that. Okay, and it's best just leave it that way. Don't FOIL out the denominator again. 54. This time we have x all over x squared minus 2x minus 24 minus x all over x squared minus 7x plus 6. Again, I'm going to have to factor the denominators to see what I'm kind of look under the hood, so to speak. So x and x, plus and minus, and probably 6 and 4 with the negative on the 6, and minus x all over, it's like a minus minus scenario, and then 6 and 1. Okay. So the first fraction is missing a factor of x minus 1. The second factor is missing a factor of x plus 4. Right. So I'm going to go x times x minus 1 minus x. I'm subtracting the numerators over the common denominator. I'll distribute in the next step. Doesn't matter what order you put the denominator in because of the commutative law of multiplication. Okay. I'm going to distribute those, x squared minus x. Distribute the negative x minus x squared minus 4x all over our common denominator. The x squares are gone, so you have minus x minus 4x is minus 5x's all over our common denominator. Okay. Okay, next, so I got 64 y squared minus 6 all over y squared plus 9y plus 18 minus y minus 4 over y plus 6. Okay, factor the denominator on that first fraction. It's a perfect square trinomial. Plus 3 plus 6. Okay, so clearly the second fraction needs a factor of y plus 3. Go top and bottom on that. Here, you can, recopy everything and FOIL out the numerator of the second fraction. Yeah, that's kind of how they do it in the book. So y squared minus 4y plus 3y is minus y, and then minus 12 all over y plus 3, y plus 6. And then subtract the numerators over the common denominator. And of course you have to distribute the negative. So I'm getting y squared minus 6 minus y squared plus y plus 12. And then your y squares cancel, and you're getting a y plus 6. So we'll have a neat little cancellation there as well with these y plus 6's. And of course you just get 1 over y plus 3. Okay, neat little answer. One more. 74. A lot in this section, really. This is probably the most writing you'll do in math in your entire life. Y minus 2 all over 12y. Okay, so our denominators, I need a common denominator. So the second fraction is missing a factor of y in top and bottom. The first fraction then is missing a factor of 4. So going top and bottom, we have 4. So we'll have, at the end of the day, 4 times y minus 7 minus y times y minus 2 in the numerator all over 12y squared. So 4y minus 28 minus y squared plus 2y all over 12y squared. And I like to put positive terms first in my numerator and denominator, so I'm going to go 4 plus 2y, 4y's plus 2y's is 6y's, and then minus 28 minus the y squared all over the 12y squared. Okay. There's no way to factor the numerator. It's what they call irreducible, an irreducible quadratic. So you're kind of stuck with it, and that would be your answer. Okay, you remember 7.5? 7.5 was on complex fractions. So you could use either method you want to simplify. So use either method. And I'm looking at problems like 1 to 39, odd. Okay, so let's look at number 6. We have 1/2 minus 1/4 all over 3/8 plus 1/16. And honestly, in my opinion, the easiest way to deal with these guys is to multiply by the LCD of all the fractions. Okay, so if you're going to add 1/2, 1/4, 3/8, and 1/16, you need a common denominator of 16, right? So that's what I'm going to do. I'm going to multiply top mod. Another way to think of it is just a number that is divisible by all the denominators. The smallest number that's divisible by all the denominators. So 16 is divisible by 2, 4, 8, and 16. So we use that. Okay, so then I distribute. You'll have 16 times 1/2 minus 16 times 1/4 all over 16 times 3/8 plus 16 times 1/16. 16 times 1/2, 2 goes in the 16 8 times, so it's just 8. 4 goes in the 16 4 times, so minus 4 all over 8 goes in the 16 2 times. 2 times 3 is 6, and then 16 goes in the 16 1 time, so it's just 1. Okay, so you end up with 4 over 7 as our answer. Okay, so that was actually the second method that I taught. Let's look at one with the first method. So 8 plus 3 over x over 1 minus 7 over x. Okay, so the second method was to find a common denominator for each term. In the terms in the numerator, find a common denominator, and the terms in the denominator, find a common denominator. Then simplify, and then rewrite it as division, and then rewrite it as multiplication, and then simplify from there. Okay, so first thing I'll do is rewrite 8 as a fraction. 8 is the same as 8 over 1, and I'll do the same thing for this 1 in the denominator. Then common denominator, right? So the 8 over 1, I needed a factor of x in its denominator, and then likewise for the 1 over 1 in the denominator. So I need an x there and there. Okay, so I have 8x over x plus 3 over x in the numerator, and then x over x minus 7 over x in the denominator. Okay, combine the numerators over the denominator in the numerator. Combine the numerators over the denominator in the denominator. It just sounds weird. And then rewrite it as division. Okay, x all over x minus 7. If you told me 20 years ago that I would be sitting here stringing that sequence of words into sentences, I would have thought you were crazy. Anyways, 8x plus 3 all over x divided by, so you change it in the multiply, x minus 7. Whoops, I already flipped it. So that's dangerous right there. That is some dangerous stuff. That makes mistakes that could cost companies millions of dollars, you know, making these silly mistakes. X minus 7 all over x. It can get people killed if you're in the wrong field. We used to have a helicopter pilot. Well, he was like an experimental helicopter pilot, and he would have to, you know, very quickly figure out how much fuel, you know, on the fly. How much fuel do I need to get from here to here? And, you know, literally he had to do all these computations in his head. If he got them wrong, you know, there's big trouble. Anyways, he was an interesting guy. He was awesome at doing arithmetic and stuff like that. Anyways, let's keep going. So I have 8x plus 3 times x all over x times x minus 7. And then we can remove a factor of x, 1 over 1. And then we have our answer, 8x plus 3 over x minus 7. Okay, so you can use either method. I'm not really worried about which method you use. I prefer the greatest common the least common denominator kind of multiply on top and bottom method. Let me look at two more, and then we'll go on to 7.6. A lot of material in this section, right? It's very hard in the summer. Anyways, the LCD of all these fractions would be x times y, right? So I'm going to multiply top and bottom by x times y. The first distribution, the x's would cancel, and I just have a y. The second distribution, the y's would cancel, and I just have an x. Downstairs, the first distribution, the x's cancel, and just have y. The second distribution, the y's cancel, and I just have an x. And that's it. You know, those aren't opposites. The y's have the same sign. 34, let's look at one of these. 1 all over x minus 2, all over 1 minus 1, all over x minus 2. Okay, I'll do the other method this time. So in the denominator, I'll rewrite 1 as 1 over 1, and it's missing a factor of x minus 2 in the denominator. So top and bottom by x minus 2. So I have 1 over x minus 2 all over x minus 2 over x minus 2 minus 1 over x minus 2. So I have 1 over x minus 2 all over, subtract the numerators over the common denominator. So I got 1 all over x minus 2 all over x minus 2 minus 1 is x minus 3. Turn it into division over x minus 2 divided by x minus 3 over x minus 2. So I get 1 over x minus 2, instead of divided by, multiplied by x minus 2 over x minus 3. And then you see there's going to be a nice cancellation right here. And you can end up with 1 all over x minus 3. I mean, you could literally, if you want to, if you get, confident enough at doing these problems, just, do your simplifications right there, and you'll have your answer. Okay. 7.6 then, we actually now apply these methods to solving equations that involve rational expressions. For these problems, to get full credit, you must state your restrictions. Okay. And you should be showing your restrictions, because sometimes you'll end up with no solutions because your computed answer doesn't work, right? Okay, so I'll be thinking of problems like 1 to 59 odd, and all you're doing is solving. Okay, so let's look at 10. I have 7 over 2x equals 5 over 3x plus 22 over 3. Okay, so the deal is more like the 7.5 problems where you're multiplying top and bottom by the common denominator. That's how you want to approach these. That's how I expect you. And if you don't do my methods, oh no, get out of town. You got to do the way I want you to do it. I have a method to my madness. You got to do it this way. Okay, so you're going to multiply both sides by the LCD of all these fractions. You may even want to write down the LCD. So in this case, I need an x, I need a 3 and a 2, so it's going to be 6x, right? Okay, so I'm going to multiply this side by 6x and this side by 6x. Okay, so this times that, 2 goes in the 6 3 times, the x's cancel, so I'll just have 3 times 7, which is 21. This times this, 6x over 3x is just 2, so 2 times 5 is 10, plus this times this. 6 over 3 is 2 again, so 2 times 22, and then there's an x, so 44x. Okay. If you didn't catch that, usually what I did in the lecture was kind of write it all out. 6x times 7 over 2x, and then you can think of 6x as like 6 over 1, and then you could factor. But hopefully you get to a point where you can do most of this in your head, right? I think you can remove the 2's and the x's, and you just get 21. Okay. So the 6x times 5 over 3x, 6x is 3 times 2 times x times 5 all over 3x. You can remove the stuff like that and you get 10. And then 22 over 3 times 6x. So you can pretend it's over 1, so it's 6 6 is 3 times 2 times 22 times x all over 3. The 3's are gone, and you get 44x. Okay? Okay, so if you need to, in the scratch work on the side and your margins, you can do all your little scratch work. But hopefully you get to the point where you can just kind of do those in your head. Anyways, once you're here, then you're going to isolate the variable. So I get 11 equals 44x. And then I'm going to divide by the 44. And I'm going to flip-flop sides. You always want x, like you're reading in English from left to right. You want to put x, and then on the other side, 11 over 44 is the same as 1 over 4. Okay, what did I not do? I forgot my restriction, right? So I would have lost points there. You got to take the denominators and set them equal to 0 if they have a variable. Okay, so 2x equals 0, so x can't be 0. Same for 3x equaling 0, so x can't be 0. Our solution works. 1/4 is not 0, so just circle it, put an arrow towards it or something. Let me know that you know that's the answer. Okay, let's move on. 22. Let's get x plus 3 over x equals 19 over x. This time the LCD is just x, so I'm going to multiply both sides by x. Here, x times x is x squared, and then x times 3 over x, the x's will cancel, and you just have to be left with 3. On the other side, I'll just be left with 19, the x's cancel. It's quadratic, so you're going to set it equal to 0. So I have x squared minus 16 is 0. And I get x minus 4, x plus 4 is 0. Set each part equal to 0. Well, what are my restrictions? Let's get that out of the way too. So setting the denominator, I can't have x being 0. Okay, so either x minus 4 equals 0, in other words x is 4, or x plus 4 is 0, in other words x is negative 4. Neither of those are restricted, so those are our solutions. Okay, next. Let's see how many more of these I got. Two more, and then we have some literal equations as well. Okay, so let's look at 30. Yeah, 3 all over x plus 4 minus 7 equals negative 4 all over x plus 4. Okay, so the LCD this time is the x plus 4. The restriction, let's take x plus 4, set it equal to 0. So x can't be negative 4 in the end. Okay, so let's go at it. Multiplying everything by x plus 4 on both sides. So on the left, this times this, the x plus 4's cancel. You have 3 left, minus 7 times x plus 4. On the other side, you just got negative 4 because the x plus 4's cancel. So got 3 minus 7x minus 28 is negative 4. Combine like terms, so negative 7x minus 25 is negative 4. Add the 25 the other side, so you get 21. Divide both sides by negative 7, so x is negative 3. That is not restricted, so we are good to go. Negative 3 is your answer. One more. And then on to literal equations. So 36, 10 all over y plus 2 equals 3 minus 5y all over y plus 2. Okay, so again, the LCD, y plus 2. Restriction, negative 2. Okay, so I'm going to multiply everything by y plus 2. Okay, so 10 on the left, distributing here, okay, 3 times y plus 2, distributing here, the y plus 2's cancel, so you get minus 5y. So you get 10 equals 3y plus 6 minus 5y. Combine like terms, negative 2y plus 6. And I'm going to move the 2y to the other side, move the 10 to the other side, and then divide by 2. Okay. Is that it? No. So this time it is restricted. So we have to throw that answer out. We don't have any other answers. Therefore, no solutions. Okay. Literal equations then, so you see these in our biology class and physics and chemistry. We want to solve for a particular variable, and in this case we want to solve for q. Okay. So first I'm going to get rid of the fractions, multiplying by the LCD, which is PQF. You don't have to worry about restrictions in these problems. So PQF on both sides. Distribute. In the first distribution, the p's cancel, leaving you with QF. In the second distribution, the q's cancel, leaving you with PF. On the right side, the f's cancel, leaving you with PQ. Okay. I need to get all the q's on one side, so I'm going to move the QF to the right. So I have PF equals PQ minus QF. Usually I'll flip-flop sides because I'm going to want to have Q on the left side. So let me just flip-flop sides. I usually flip-flop in my head, but factor out the Q on the left there, and then finally divide by the PF, P minus F. So you get PF over P minus F, and that would do it. Okay. So expect one of those literal equations. 7.7 then is the application section. So expect a motion problem, so probably like one motion problem, or a sampling problem. I like the biology type problems where you capture some animals and put tags on them and then estimate the population, or a one triangle problem. So those are the similar triangle problems. So let's take a look at each one. So this is number 8. Let me get my book so I can read the question. Sorry, you should pause the video while I get the question. Okay, hold on. Okay, so it's on page 556, and it says, the joys of the Pacific Coast. You drive 90 miles along the Pacific Coast Highway and then take a 5-mile run along a hiking trail in Point Reyes National Seashore. Your driving rate is 9 times that of your running rate. If the total time for driving and running is 3 hours, find the average rate driving and the average rate running. So the motion problems, you can set up a chart. Okay, so there are two things, the driving and then the running. Okay. Then I do my chart. And usually I give you like a chart, but you have to fill it all in. Okay, it'll be D, R, and then T equals D over R, and it's always, it's from distance equals rate times time, and you solve for time, D over R. Okay. Right. So again, your driving rate is 9 times that of your running rate. In the end, we want to find the average running and driving rates. So the running rate we don't know, but the driving rate is 9 times that. Okay, so 9 times X. You drive 90 miles along the Pacific Highway, so you went 90 miles driving, and then you went for a 5-mile run. Okay. So now I can get the time expression is 90 over 9x. I can simplify that. That's just 10 over x. And then the time expression here is 5 over x. And then the sentence you're driving, the sentence, if the total time for driving and running is 3 hours, find the average rate. So the total time, that's this time plus this time, is equal to 3 hours. Okay, so it's 10 over x plus 5. I'm not going to put one of those because this looks an awful lot like the work formula. There's no way I'm putting one of those work problems on here. Okay, those are a bit silly in my opinion. Anyways, the sum of the time is 4 hours, and then we're going to solve this for x. That'll give us, and please write up your answer in a full sentence. Anyways, the LCD in this case is x. So now multiply both sides by x. Distribute. So get 10 plus 5 equals 4x. So 15 equals 4x, and then that implies x equals 15/4. Seriously? What did I screw up? It's 3, not 4. I must have I read the wrong problem or something. If the total time for driving and running is 3 hours, so I put a 4 there, it should be a 3. Sorry about that. So this is 3, 3, 3, and then dividing, you get 5. So I drove at 45 miles per hour, and I jogged at 5 miles per hour. Okay, very good. Let's do one of the biology type problems. So this is 22 in the book. According to the authors of Number Freaking, that's some sort of periodical, in a global village of 200 people, 9 get drunk every day. Okay, so the number of drunks versus the population. Okay, in some village out there in, I don't want to say where I would think that would be, but 9 all over the number of people in the village. So there's 9 people in that village of 200 people that get drunk every day. And you want to use that to find out how many people in the world get drunk every day. Okay, and they tell you there's 6.9 billion people on the planet. Okay, so I'm going to write 6.9 billion, but I'm going to write it completely out. So 6.9 billion, 6 billion, 900 million. Okay, and then I want to know how many people, based on that one city, how many people do I think get drunk every day in the population? Okay, so I'm going to cross multiply this guy, and I get, what do I get? 200x equals 9 times 6900000000. I'm going to leave it like that and just divide both sides by 200. Okay, and then hopefully my calculator will be happy with giving me an answer. Let's see what it says. 9 times 6900000000 divided by 200, and it gave me an answer, and I'm using the TI-30X. 310500000. 123 123. If I would be fine with that answer. Just write people get drunk every day. You should never start a sentence with a number, but okay, I don't want to have to write out that number 3 million times, so I understand. 310,500,000 people get drunk every day based off that one city. Obviously, if you pick a city that has where they don't have nice water to drink, they may be drinking a lot more alcohol, so maybe more people get drunk in that city. And if you use that city to kind of try to guess the number of people in the population that get drunk every day, that could be, you could get yourself into trouble. So you need to be careful with your statistical methods. Take a class in statistics. Okay, there's my little ad for the statistics classes. Okay, let's look at one of these similar triangle problems then. No, let's pick 28. So we have, this is one of the triangle within a triangle scenarios, and we're kind of looking for corresponding sides and building a proportion based off that. I think I actually did this one in the lecture. If I did, I apologize. So we want to figure out what the heck x is, and we're also given that this length is 5 inches. Okay, so the bigger triangle I'll put in green, and then the little triangle is sitting inside of it, and I'll put that in blue. Oops, it did not change color for me. Here's the other triangle inside of it. So we want to make ratios with corresponding sides. So 4 over 5, the little triangle side to the big triangle side, that are corresponding sides. And then on the other side, the base sides, right? So the small triangle has a base of 5, and then so you have to make sure you get small triangle material information in the numerators and then large triangle information in the denominators, or vice versa, as long as they horizontally line up. Okay, so horizon, horizontal, like when you look out at the horizon. Anyways, and the other side, the long side, the long base is this length, so it's not just x, it's the 5 plus x, and then you could cross multiply and solve for x, right? So let's see what we get. 4 times 5 plus x equals 5 times 5 is 25. Get 20 plus 4x equals 25. 4x equals 5. Really? 5/4 inches? That don't sound right. Let me look. Yep, it's right. Okay, well, I'm surprised. Okay, so that does it for the review. Thank you for watching, and good luck on the next test. Okay, bye-bye.